Okay, so this is when will a double replacement reaction produce a precipitate? So remember, a precipitate is a solid, an insoluble solid that kind of rains down into solution. So we're going to use reference table F to determine that. So we're going to use table F to determine which products are soluble, which means dissolvable, or not. So here on table F, I recommend that right on your reference table, you write when it says ions that form soluble compounds, these are going to be aqueous, meaning they will dissolve. The exceptions to that would be solids, so an S for solid. On the right side, anything that is insoluble will not dissolve, so that's going to be a solid, and anything that's an exception to that will be aqueous. So, for example, if I had a compound like, table salt, sodium chloride, I'm going to look for generally the anion, the negative charge, because most of these on here are negatively charged. You will notice you do have some of these that are positively charged, and those are soluble with no exceptions. So what I would do in this case of NaCl, which, by the way, from my experience, I know is soluble, I'm going to say Cl is a halide right here. So halide is soluble with the exceptions of silver, lead 2, or dimercury. So in this case, sodium is not one of those exceptions, so it would remain aqueous in solution. However, if I had silver chloride, I know that that is an exception, which means that would not dissolve in water. It would stay a solid. It would be insoluble. On the other side, if I had something like calcium carbonate, so once again, I would look for my anion, which is carbonate. Here it is. Carbonate is insoluble except when combined with group 1 or ammonium. So here we have calcium. Calcium is in group 2, alkaline earth, which means it is not an exception, which means calcium carbonate would be a precipitate. It would be solid. However, let's just say we have lithium carbonate, which actually would be this. So lithium is in group 1, which means it is an exception, which means it would be aqueous. So the question says, when will you have a precipitate in a reaction? First of all, it has to be a double replacement reaction. That's the only time. And then we'll use table F to determine that. So here we have our example. Silver nitrate and sodium chloride. They're both aqueous solutions. So here we have our positive. This is our negative. Here's our positive. Here's our negative. So in a double replacement, we're going to switch our positive partners. So we're going to have the silver with the chlorine, and we'd have to crisscross our charges, but in this case we're good. +1 and -1. And I don't know my phase yet, so I'm going to leave that there. And we're going to have the sodium with the nitrate, and we're going to figure that out. So then it says check table F to see if the products are solid or part of the solution aqueous. So I have silver chloride and sodium nitrate. So I'm going to go back. Sodium nitrate. Nitrate is here, and I've got a lot of writing going on, but notice that nitrate is soluble with no exceptions, which means that will be aqueous. However, with the halides here, silver is an exception. So that means the silver chloride is our precipitate and the sodium nitrate is part of the solution. So if you were to have a test tube or something, you would have a solid down here, which would be the silver chloride, and the part of the solution right there, which would be that. Then let's try this one. So again, we have a double replacement reaction. So this is our positive, negative, positive, negative. By the way, calcium's a positive too, because it's going to matter later. So potassium is now going to be with the hydroxide, and that's K + 1, OH - 1. So that's balanced. Figure out our phase in a second. Calcium's a +2, Cl's a -1, so that's going to crisscross to that, and we'll figure that out. So now we have hydroxide and a chloride in terms of our anions. So it's going back. Hydroxide is here, which is insoluble except with group 1, calcium, barium, strontium, or ammonium. So look, this is an exception. So, oh, sorry, that was hydroxide. Oops. So hydroxide, group 1. It's an exception, which means this is going to be aqueous. And chloride is soluble except with silver, that's lead too, sorry, and dimercury. So those are not exceptions. So if both of your products are aqueous, we don't have a precipitate being formed. So again, you can only have a precipitate when you have a double replacement reaction, and you have to use reference table F to figure that out. If you have any questions, please reach out. Thank you.